Okay, it's March 28th, 2022. This is Frank Gordon's lattice energy converter replication experiment. What I've done is made up it's called a counter electrode, piece of brass plate, 0.9 millimeters thick, bonded to a piece of plywood to keep it flat. It's flat to about 0.1 millimeters. There's two insulators at the end here, which is just a few layers of electrical tape, which will allow me to put a plate on top that will come within about 0.6 millimeters of the bottom plate. Attached to the cell itself is a 10 mega ohm voltmeter. It can resolve 0.1 millivolts. There's a load resistor of 1 mega ohm nominally connected across the circuit to provide a load and prevent stray currents from influencing the meter too much. I've shortened the leads on the meter so that it's not showing a result of induced EMF nearly as much. And it's pretty stable. It may flicker 0.1 millivolts just sitting there, but that's about it. These are several working electrodes that I've made over the last 2 weeks. Each of them's been made with different voltages and currents and solutions and so on. The back is plated in some cases it's not. The brass material that it's plated to, and it's an iron plating, the brass material that it's plated to is the same brass material as the counter electrode on the wood plate here. It's cut from the same piece actually. I used 3 different solutions to do the plating, and I got different results with each solution to some extent, but they all produced a decent plate after I got it figured out. Some of them were sodium citrate and ferrous sulfate. I would get good coats from that. It would take a while, but the problem is that the solution is opaque. You can't see what's going on with the bubbling in the tank, and quite a bit of magnetite formed on some of them, but not all of them. And you end up with quite a bit of sludge in the bottom of the tank, which appears to be magnetite also. Second solution I used with muriatic acid. It's better in that it's clear. You can see the bubbles form, and it stays clear throughout the process. I also use ferrous chloride and potassium chloride. It does a fast, heavy plate. It tends to rust easier for some reason. I haven't played with it a lot, but you get an orange coating forming fairly quickly. The rest of the plates didn't show much rust even after a couple of weeks. Now some of them I've had water droplets doing an experiment on, and there is some rust from that, but otherwise they seem to stay pretty clear. One of the things I do to see how well the coating went is use a magnet and place it on there. You can see it sticks to all of these. Obviously it won't stick to the brass, but it does indicate there's a fair presence of iron on top of it. Okay, so we'll look at the assembly of this. If we take one of the plates and connect it to the terminal of the meter and place it on top. Again, the gap should be about 0.6 millimeters. We can put something on top of it, push it down a little bit. The plate, it may be bowed slightly, but it's pretty good. You can check the resistance. It should show the resistance of the 1 mega ohm resistor, which is 1.049 within spec. I don't leave it on ohmmeter too long because the ohmmeter can charge the cell, both the capacitance, and if it's acting like an electrochemical cell, it could charge it because ohmmeters produce a voltage. It's the way they work. Okay, but as you can see, I'm not getting any voltage here at all. And this is what's occurring on all of these. Even if I wait a half an hour, I'm not going to see anything. Okay, so I'll take that one off and we'll put another one on. Okay, give it a little push and put a little bit of weight on it. As you can see, we're not getting anything. Well, we'll let that one sit a little bit longer and see what happens. In the meantime, I'm going to take an electrode out of the tank and I'll wash it and prepare it. Okay, so this is the one that I just took out of the tank. I've dried it with a paper towel, and I've heated it up with a 60-watt light bulb, just an inch or two away from it for, say, 30 seconds or so. And we'll put that on, give it a push. And as you can see, there's a small voltage there. I'll just watch that for a minute. Okay, it doesn't seem to be going anywhere. We'll take this off. And you can see a layer of condensation on there. That's because it wasn't perfectly dry. Even though it's been under the heat lamp and it more or less looks like it's fairly dry, it's not. I end up with a bit of condensation, which produces the voltage because it's acting like an electrolytic cell. So we'll do this again. Get rid of the condensation, put it back. And it's producing quite a voltage. We'll take it off and look, and sure enough, there's layers of condensation here and here. I'm going to take it off and put it under the heat lamp again and give it another 30 seconds. Okay, we'll try that again. Okay, we've got a fair bit of voltage. Let's see what's going on. And again, you can see condensation. Even though it seemed to be dry, it's not. I'll get rid of that. And I'll put it under the heat lamp again. Okay, let's try that again. Push it down. Okay, we still have voltage. Yep, I can see condensation again. I'll get rid of that. Now looking at this, I don't really see anything on there that looks like it's moisture, but it could certainly be trapped under there. Okay, that time it's much less. There's still some condensation there. We'll heat it up again. I'm not seeing anything. Still a little bit of moisture there. Less moisture. I'm going to heat it up one more time. Okay, try it again. Still some moisture. It seems to get trapped in the pores. Now if I let this thing dry for 10-20 minutes, put it on, I won't get any condensation, but I won't get any voltage either. And another unusual thing, if I take this out and I let it sit for an hour or two, something like that, I wash it in water, put it on, I don't seem to get the condensation effect. In other words, it doesn't seem to absorb the condensation. It seems to have to be into the tank to do that efficiently. I still need to pursue what's going on there exactly, but there seems to be something going on there. Okay, so we've got no voltage and we've no condensation. It seems to be dry right now. So that's basically that story. There's one other thing I would illustrate. If I take one of these other electrodes and I take, this is distilled water, I'm just going to put a few drops on here. Okay, and I take the electrode, put it on there. It produces quite a voltage. It's acting like an electrolytic cell. I assume the water's in contact with both sides of the plate. I have gotten up to 470 millivolts doing this. I have seen the polarity change. Like you can see right now, it's cranking down. The voltage is minus, but it's dropping. Typically it'll go through 0 and then go plus and crank up to some relatively high voltage. I've even gotten 400 odd millivolts into a 10K load resistor. But you're starting to talk about a significant fraction of a microamp. Okay, but again, you have to have moisture between the two plates. When they're dry, I get absolutely nothing. Okay, so you can see the polarity change there. So I'm going to take that off. If I let that go, it would crank up to some high voltage. If I take a plain brass plate and connect it up, leave that on top. So 2 brass plates with a little bit of water in between. That also produces a voltage. Okay, typically it's not nearly as much. I might see 20 millivolts or something like that from doing this. But it's kind of peculiar that both metals being the same would produce anything. With the iron coating, I see considerably more. I have a piece of galvanized metal. I don't have it right here. If I put that on, which is galvanized metal, zinc on steel, I also get a fairly significant potential, maybe a couple of 100 millivolts. Again, you have to have moisture in between them. Okay, I think that sums up this video for now.